Good morning to you all.
Good morning, ma'am.
So what is the issue in joining the Zoom lectures? Because the number of participants are very less. Whether the hostelers, anyone from hostel, did you join in the Zoom session? Hostel students, please, one of the hostel student, unmute your mic. Otherwise, I have to cancel today class and...
Yes, ma'am.
Right. Is there any issues in joining the Zoom session from hostel?
Sometime coverage problem, ma'am.
Coverage problem anywhere is. Otherwise, if you have any issues in joining the Zoom session, I have to cancel it and I have to conduct the physical lectures, right? So today we can't, because most of the staff are on the token strike regarding the tax for the salaries, right? So if the hostelers are, or some of the students are not liking to participate in the Zoom session, I have to cancel. But anyway, with a physical class, only there are 6 or 7 sessions only there are, right? Within that, we have to complete all the session. The March 3 is the last day of your session. So we have to go fast. Because of that, avoiding that difficulties, I am arranging some Zoom sessions. But most of the students, only the 50% of the students are participating through the Zoom session. So if you are not cooperating, then I have to cancel the Zoom sessions and we have to conduct the physical sessions, but only 6 or 7 lectures. Within that, we have to complete all the sections. So we will go fast. So if the today attendance is very poor, then no more any Zoom sessions. I will not arrange, right? So only the physical sessions, you have to learn it. So now I'm starting the next distributions. Depending on the number of participants, then I will stop with a half of way, right? Right. Last sessions, we studied about the binomial distribution. That is a probability discrete distribution. So today we are going to introduce another discrete probability distribution that is called Poisson distribution. Here, this I is not that is a silent. Right. Then what about the Poisson distribution? Right. It is little bit different from the binomial distribution. In the binomial distribution, actually we are looking at the number of successors. Here also we are looking at the number of events that occur in a unit. That means, for example, that unit may be an interval or length or area or space or volume. Right? Per unit of space or interval or area, in that we are looking at how many events are occurred. Right? So here also we are looking at the number of events that occur in an interval, events per unit. It may be time, length, area, or space. For examples. Now here we are looking at 3 examples. Number of customers arriving in 20 minutes time. So we are looking at in a certain interval how many customers are arriving. Here the per unit is 20 minutes time. In the second example, number of strikes per year in the US. So here per year is a per unit. How many strikes occurred per year? Then number of defects per lot. Right? But in the binomial, how we look at number of trials? We are looking at the number of successes in n trials. So here, instead of n trials, here we are looking at per unit. So 20 minutes or per year or per lot, 15 minutes time. Similarly, here we are looking at. And also here we are not classifying success or failure. We are not classified, but number of, we are looking at how many. So how many customers are arriving in 20 minutes. Right? So number of customers. Right? This is the difference between the Poisson and the binomial. Then characteristics, like a binomial, we are looking at the 4 characteristics. Fixed number of trials, independent trials, probability of success is same for each and every trial. And there are only 2 possible outcomes. Here, little bit different. For the characteristics of a Poisson random variable, it consists of counting number of times an event occurs during a given unit of time or in a given area or volume. Right? This unit of measurement may be different depending on the situation. Right? But binomial, what we did, we counted how many successes out of n trials. Here we are counting number of events occurred during a given unit of time or in a given area or volume. Then the probability that an event occurs in a given unit of time, area or volume is same for all units. Right? So the probability of occurrence, that is also probability of success, like in the binomial. Here we are looking at the probability that an event occurs in a given unit of time, area or volume, which is same for all units. Third one, the number of events that occur in one unit of time, area or volume is independent of the number that occur in any other mutually exclusive units. For the disjoint units are there because 9:15 to 9:30 or 9:30 to 9:45. Within that, the number of events that occur in one unit of time is independent. Volume is independent of the number that occur in any other mutually exclusive events. Right? Then the mean number of events in each unit is denoted by lambda or mu. That is actually proportional. Suppose in 15 minutes, average number is 2. Then in the 13 minutes, average number is 4. That is proportional to the unit. And it is denoted by lambda or mu. Right? So these are the characteristics of a Poisson random variable. Right. Then the probability distribution function. How we are defining the probability distribution function, like a probability of X, that is number of events. X denotes the number of events per unit of time, with a unit of time. That is actually X is a random variable, a Poisson random variable. Then that is equal to small x equals e to the power minus lambda, lambda to the power x over x factorial. Here x integers, that is a positive integers because number of events that occurred. But here we don't have the maximum number because we can't say that per unit, for for example, 15 minutes of time, how many customers will arrive? We can't definitely specify that number. During a year, how many strikes will occur? We cannot define the maximum number. That's why here it's continuous up to infinity. So x is equal to 0, 1, 2, 3 and so on up to reach infinity. Right? So here only if we are looking at this one, it is depending on the lambda. E is a natural base, that is 2.718, that is constant. But in the calculator direct away, we can calculate e to the power minus lambda. There is a e to the power x function is there in the calculator. Right? And the lambda is a expected number of events in the unit. That is mean number of events in a unit. Suppose, for example, in a 15 minutes time, 5 customers, on average, 5 customers will come to get the service. In 30 minutes time interval, 10 customers, on average, 10 customers will come to the service. So only if you want to calculate the particular random variable has a Poisson distribution, and it's to calculate the related probabilities, only we need the lambda, expected number of events per unit. And E is equal to 2.71828. It is a natural logarithm. And capital X denotes the number of events per unit. If you want to calculate the 2 units, 2 events occur, then probability of X equals 2. If you want to calculate the probability more than 2 units occur, then probability of X greater than 2. Then accordingly, we have to apply this formula. So as this formula depending on this lambda expected value, here the lambda is called parameter for a Poisson distribution. In the binomial, what are the parameters? N and P. Number of trials and the probability of success. But in the Poisson distribution, the parameter is expected number of events in unit. Right? And so accordingly, this formula, lambda, which is the mean or expected number of events per unit, is the parameter of the Poisson distribution. Then shape. Like a binomial also, when P is equal to half, probability of success is half, it is symmetrical. Otherwise, it is a right or left skewed. But in the Poisson, it is a right skewed and the symmetrical. But when the lambda is very small, it is a right skewed. And the lambda is getting large, then it is approximately symmetrical. Here 0.5 lambda, that is the average number of events occurred per unit. That is the right skewed distribution. But when lambda is large, 6, it is a symmetrical. Then characteristics. What is about the mean and the variance and the standard deviation? Here the mean is lambda, expected value, right? But variance also lambda. If X has a Poisson distribution with lambda parameter, then mean and the variance both are same. That equals lambda. Then standard deviation is square root of lambda. Variance of X is equal to square root of lambda. So here we are summarizing the Poisson distribution in one slide. Now we are saying that it is a Poisson probability distribution with parameter lambda. Then we can denote this by X follows Poisson distribution with parameter lambda. If then the probability distribution is given by probability of X equals X, that is e to the power minus lambda, lambda to the power X over X factorial. Then X takes the value 0, 1, 2. This is the full definition of a, suppose if we are asking to define the Poisson distribution, then in such manner you have to write it. Where what is X? X is the number of units per unit, number of events per unit, and lambda, mean or expected number of events per unit. And then this mean is lambda, variance is also lambda, mu x, sigma squared x, and the standard deviation, if X is a random variable, then that is square root of lambda. These are the notations here we have, right? Then now we are taking an example. Cars passing along a particular road at random with an average 3 cars per minute. Find the probability that in 1 minute, these are the probabilities, right? Now here, we have to first define the random variable, right? Now you put in the chat box, what is a random variable to this example? From the first statement, you can identify the appropriate random variable for the given scenario. Put in the chat box. You can use the notation X or Y. Then what is X? First statement is that. Regarding when we are calculating the probabilities based on the probability distribution, this kind of pattern you have to follow. But it's a random variable. Define a letter X or Y, then define what X denotes. Like in the binomial, we define number of defects out of 10 trials. Or number of customers out of 10 trials. Similarly, here also you have to define. It's regarding we are looking at the cars. How many cars are passing along a particular road. So based on this one, you can define the random variable. Put in the chat box. Number of cars passing along the particular road per minute. That's very good, right? Per minute of time, how many number of cars are passing? Right. This is the appropriate random variable, right? Then, what is the distribution, this one? Can you write the distribution in the notation form? If this is the parameter variable, number of cars along the particular road, with the average of 3 cars per minute, with the average of, that also it's better to indicate with the average of 3 cars per minute. Then based on the previous introduction to the Poisson distribution, here only we know how many cars, average cars are passing along the road per minute. So only the one parameter we have to know, that is lambda is equal to 3. So it is a Poisson random variable with Poisson distribution with parameter 3, right? Then accordingly, we have to calculate the probabilities, right? So now we are looking at here, looking at how we are writing. Let X, now whatever you can note it, right? X, number of cars passing along a particular road with an average of 3 cars per minute. It is better to write the parameter also in the statement, right? Then according this random variable, we can assume that X has a Poisson distribution with parameter 3. 3 is an average number. Then if X has a Poisson distribution with parameter 3, then you can write this probability distribution function. That is probability of X equals X, e to the power minus lambda, lambda to the power X over X factorial. Here we know that for a certain case, lambda is 3. So e to the power minus 3, 3 to the power X over X factorial. Then what are the possible values for X? That also you have to give. That is 0, 1, 2 and so on. So only for these values, X has the probability of X is defined by this one. For other values, suppose X is equal to minus 1 or X is equal to minus 2 or X is equal to half. In that case, this is 0. The probability will be 0. Only these integer, positive integer values, you can calculate the probability using this formula. For other cases, the probability will be 0. Right? So now for part A, now we are taking what is the probability? Exactly 3 cars passing. So now probability of X equals 3. So now this is actually our formula where X is coming. In that case, you have to substitute 3. So e to the power minus 3, 3 to the power 3 over 3 factorial. Right? So that is equal to 22.40%. That means, what is the interpretation of this one? There is a chance or likelihood or probability or possibility that (22.4%) of chance that 3 cars pass along a particular road in a per minute time. In a 1 minute time, there is a 22.40% of chance that 3 cars pass along the road in a minute. Right? Next one, fewer than 3 cars passing. So that is probability of X less than 3 because fewer than 3. So X less than 3. If X less than 3, then possible values are 0, 1, 2. Then for when 0, e to the power minus 3, 3 to the power 0 over 0 factorial plus 1, e to the power minus 3, 3 to the power 1 over 1 factorial plus e to the power minus 3, 3 to the power 2 over 2 factorial. Right? By using the calculator, you have to find out the value. Right? So then based on that one, you have to convert in the percentage. After that, using that percentage, you can interpret what is the probability that fewer than 3 cars passing along the road in 1 minute time. Right? Third probability, no cars passing. Probability of X equals 0. There is no cars. Then the value will be 0. Then e to the power minus 3, 3 to the power 0 over 0 factorial. So here 3 to the power 0 also 1, 0 factorial also 1, then e to the power minus 3. Then by using your calculator, you can get the value for e to the power minus 3. Right? Then fourth one, at least 2 cars passing. So minimum 2 or more than 2. X greater than or equal to 2. That is X equals 2 plus X equals 3 and so on. But here we don't have actually maximum value. So we have to apply the total probability equals 1. So if we are subtracting the values for 0 and 1 from total probability 1, then you can get the probability for this one. So this is actually probability of x greater than or equal to 2. That is 2, 3 and so on. This is same as 1 minus probability of x less than or equal to 1, because we know that for any probability distribution, the total probability is 1. So we are taking the complement of the complement for the event. Then that is equal to x less than or equal to 1 equals 0 and 1. So 1 minus e to the power minus 3, 3 to the power 0 over 0 factorial, plus e to the power minus 3, 3 to the power 1 over 1 factorial. Then you can get the probability. Right. Now here part B, little bit different, right? Find the probability that in 2 minutes, exactly 5 cars passing. Here for all these cases, we are looking at the probabilities 1 minute time, right? Probability in 1 minute. So for a 1 minute time, your lambda is 3, average number. But here, we want to calculate the probability in 2 minutes time. So in this case, what will be your lambda? Put in the chat box. In this case, what is the lambda? Put in the chat box lambda value. For a 1 minute, there is a 3 cars. Now we want to looking at in 2 minutes, what is the average number of cars will pass? When we are looking at the characteristics, I told that it is a proportional. The number of events are proportional to the unit time, right? So, if it's a 1 minute 3, then for the 2 minutes 6, right? So now we are looking at average number of cars passing in 1 minute. It is a 3. So average number of cars passing in 2 minutes, it is 6. Then average number of cars in 5 minutes time, then 3 into 5, 15. Similarly, you can find out when we are extending the time interval or other thing, then you can find out the average number because it is a proportional. So in that case, we are defining another random variable y, that is number of cars passing along a particular road with an average of 6 cars per 2 minutes. Right? Now our time, all the probabilities for this random variable, all the probabilities are related with the parameter 6. Then find the probability that in 2 minutes exactly 5. So probability that is, then if y follows Poisson distribution with 6, then probability of y equals y, e to the power minus lambda, lambda to the power y over y factorial. That is e to the power minus 6, 6 to the power y over y factorial. Then y is equal to 0, 1, 2 and so on. Then that is equal to e to the power minus 6, 6 to the power 5 over 5 factorial. That is 0.1606. That is 16.06%. Right? So what is the interpretation of this one? There is a probability of, there is a chance or possibility of 16.6% that 5 cars will pass in 2 minutes time. The probability that 5 cars will pass in 2 minutes time is 16.06%. In 2 minutes, what is the probability of passing 5 cars along the particular road? That is 16.06%. Then find the mean and standard deviation of cars passing in 4 minutes time. Now, in a 4 minutes time, what will be the parameter for this Poisson distribution? Can you put in the chat box? In 4 minutes time, what will be the parameter for the Poisson distribution? That means the average number. That is a 4 minutes, 12. Right. Then what will be the mean? That is exactly, that will be 12 will be the mean. Then the standard deviation. Right. Average number of cars passing in 1 minute 3. So average number of cars passing in 4 minutes 12. Then we are taking another random variable Z. That is number of cars passing along a particular road with an average of 12 cars per 4 minutes is follows a Poisson distribution with parameter 12. Then we know that the expected value and the variance are same for the Poisson distribution. That is given by the average number. That is 12. And the standard deviation is square root of 12. Any doubts you have in this Poisson distribution? Now, almost, what are the possibilities we can ask from the Poisson distribution? Almost we summarized in this example, right? So if you have any doubt, then you can put in the chat box or you can unmute your mic and you can ask. Right. Right. Now here, you write the random variable for this, read this exercise and write the random variable for this one. number of reportable accidents within average of 7 per month. Yes, that's perfectly right, right? Number of reportable accidents, not within, with number of reportable accidents with average of 7 per month, right? So a large manufacturing plant has averaged 7 reportable accidents per month, right? So it has, because only we know the distribution parameter, only average. So here we can assume that, or they are saying that it has a Poisson distribution with mean 7 per month. Right. Then what is the probability of exactly 7 accidents in a month? So now here we have a random variable X, number of accidents with an average of 7 accidents per month or reportable accident. Then X has a Poisson distribution with parameter 7. So then probability of X equals X e to the power minus lambda, lambda to the power X over X factorial. That is e to the power minus 7, 7 to the power X over X factorial, where X is equal to 0, 1, 2, and so on. Then that is e to the power, we know that probability of exactly 7 accidents. Please mute all of your mics. Then probability of X equals 7, because we need the probability of exactly 7. So that is e to the power minus 7. Where the X values are coming, there you have to put 7. E to the power minus 7, 7 to the power 7 over 7 factorial. Right. Then for the next part, what is the probability? 7 or fewer accidents. 7 or fewer. So that is X less than or equal to 7. Probability of X less than or equal to 7. That is Px is equal to 0, Px is equal to 1 up to 7. For each everyone, you have to substitute the appropriate X values and you have to calculate. And you have to complete these exercises, right? E to the power minus 7, 7 to the power X over X factorial. 0, e to the power minus 7, 7 to the power 0 over 0 factorial, plus when X takes 1, e to the power minus 7, 7 to the power 1 over 1 factorial, and you have to continue up to 7. Right. Now you read this next paragraph and find out what is the distribution or probability distribution of the number of reportable accidents in a year based on this paragraph. Read it and put in the chat box your answer. when we are reading this one, this is this year, right? This year, a safety culture change initiative attempts to reduce the number of accidents at the plant described in the above exercise. They are taking some measures to reduce the number of accidents. There are 66 reportable accidents during the year. Right. Suppose that the Poisson distribution of the previous exercise continues to apply. This Poisson distribution is again continue to apply. Then accordingly, what is the distribution of the number of reportable accidents in a year? Now here we have to specify the distribution. But in the previous, this is a Poisson distribution with average number of 7 per month. So only here we are looking at the unit of time. Here we have a year in a year. So what is the distribution? For a year, what will be the lambda? Put in the chat box. $84, right. Per year, the accidents, number of reportable accidents is 84. They also say that suppose that the Poisson distribution of the previous exercise continues to apply. Accordingly, now what is the distribution of the number of reportable accidents in a year? It has a Poisson distribution with average of 84 reportable accidents per year. It is a Poisson distribution with the average of 84 accidents per year. Whenever asking to calculate specify the distributions, you have to specify the distributions with the name and the appropriate parameters. If you want to specify the binomial distribution, then you have to specify what is the number of trials and what is the probability of success. If you want to describe the Poisson distribution, then you have to specify the average number and what is the unit of time here we are considering. What is the unit we are considering? So similarly here, according to this statement, they say that it is a Poisson distribution. But we have to give the Poisson distribution for year time. So per month 7, so per year 84. So it has this random variable has a Poisson distribution with average number of 84 reportable accidents per year. This is the answer for this case, right? Right. Now here, another 2 or 3 exercises. Here I am leaving as the exercises. And then you have to complete all these exercises. Right. Now, we completed the discrete probability distributions. In the discrete probability distributions, first we look at what is a discrete random variable and what is a continuous random variable. Right? And then we define the discrete probability distribution and the continuous probability distribution. And also then we calculated some probability or created some probability distributions based on the random experiment. In that case, how we can assign the probability distributions for the random experiments. And then we learned how we can calculate the expected value and the variance and the standard deviation for a discrete probability distribution. And also then we extended the discrete probability distribution for the 2 common theoretical distributions which are applicable to the business scenario. One is the binomial and one is the Poisson. Then in the binomial, we define what is a binomial random variable and what are the characteristics for the binomial random variable and what is the binomial distribution and what are the parameters and how we can calculate the binomial probabilities using the binomial distribution with the use of calculator. And then today we introduce the Poisson distribution and what is the Poisson random variable and what are the characteristics for the Poisson random variable and how we can define the Poisson probability distribution and what is the parameter and what is the mean and what is the variance and what is the shape and how we can calculate the Poisson probabilities using the calculators. Right? Then only there are 147 students. So there is no any Zoom classes for those students, right? Until the physical classes completed, right? So from tomorrow onwards, we have to go very fast because there are the statistical continuous probability distribution, then sampling distribution, and then we have to have estimation, hypothesis testing, and the regression analysis. So tomorrow we have to complete the normal distribution and the sampling distribution, right? All the exercises, you have to take it as a homework and you have to complete it, right? Only one example I will explain in the class that is only applicable during the time, right? And then I have to go very fast, right? Then there is a learning materials are there and for the self-learning times are allocated for you. So you have to learn yourself. Then don't make any compliance regarding I am going fast because I can't do anything, right? Because today you look at how many participants are there, even it is you are during the class time. Because of the strike, here I put in the Zoom class. I don't need to take today lectures, but for your benefit, here I arrange the Zoom lectures. But only 149 students participated in the class, even for the Zoom. So further, there is no any Zoom classes for you, for your batch, right? Because the attendance is very poor. For the physical class, how many students are coming? That is, I never mind it, right? But I will go fast because before March 3rd, I have to complete all these sections. And also, there are 2 more assignments also we have to have. So, within that, nearly 3 weeks time, we have to complete everything. So, 3 weeks time, how many lectures? Only 6 lectures. Each week, 4 hours. Or actually 3 hours, but I am taking the 4 hours. Nearly 6 hours or 7 hours lectures we are taking per week. But from the next week onwards, only 4 hours lectures I will take, right? And I have to go very fast, right? And also next week you will have LMS assessment, but you have to bring your device with a proper network. And in the exam hall, you have to do your continuous assessment. The continuous assessment will cover probability and the discrete probability distributions and the continuous probability distribution and the sampling distribution. These 4 sections will cover, right? Probability, discrete probability distribution, continuous probability distribution, and the sampling probability distribution. All the notes I uploaded, right? And most probably tomorrow we have to complete continuous probability distribution and the sampling distribution. And for these 2 cases, the reading materials and the lecture notes uploaded. So when you are coming to the tomorrow class, be ready with at least you have to read that material and bring your printouts, the lecture notes printouts, bring it. Then what are the things I have put in the multimedia projector? Some answers you can note it, right? So tomorrow 8:30 to 10:30 you have the lectures, physical lectures, and then you have to complete it and be ready for the next continuous assessment that will come in the next week. It may be Wednesday or Thursday you will have the assessment. Right? Okay. So tomorrow morning 8:30 we will meet in the lecture hall.